You probably have seen these websites where you can upload your PDF files and then you can chat with these documents that you uploaded. Now, in today's video, we are going to be doing exactly the same, but we'll be creating our own user interface. So here is how our app is going to look like. You will be able to simply drag a PDF file, or it can be any other file type, and then ask questions directly from that PDF file. Then you will get a response. So by the end of it, it's similar to what you will see on something like chat PDF. So for example, here we have the chat PDF. In order to use this, you need to simply drag your PDF file. For example, I'm uploading the Constitution of the United States, right? And then it kind of creates a summary. But then after that, you can simply interact with it. So let's say how many states are in the USA? Sorry. Okay. And then it's actually using ChatGPT at the backend. And based on ChatGPT's data, as well as the data that you have in your PDF file, it comes up with an answer. So let's say it doesn't provide the information on the current number of states in the USA, but as of 2021, so there were 50 states. So this is like a way we are going to be designing a very similar chat app here. Now, all the required packages are listed in this requirements.txt file, but if you face any errors, you might have to install some other packages. Just do those, right? So now I am in a directory and there are just two files. One is app.py, where I'm going to be putting all my code. The second is the requirements.txt. So first, let's install all the required packages. So I'm going to use, say, pip install our requirements.txt. So essentially, it's going to go here and pick all the packages one by one and install them, right? I have already installed these in my virtual environment, so I don't need to do that. One other tip, make sure that you create a new virtual environment for each project. So if you have Python and Conda installed, you will do it something like this: Conda create dash and then your virtual environment name, right? I already have one that I'm using, my env, so I'm not gonna do this step. Now, as I said, we're going to be using to create. Now, in the basic form, first let's create a structure of our graphical user interface, and then we will add more components and explain what's going on. So first I'm going to import Streamlit. So I'm going to say import Streamlit as st, right? And then let me add this code so that it's visible what's going on, right? So in Streamlit, I'm going to create a vertical sidebar. Okay. If you saw my like the start of the video, there is a sidebar which has some information. So let's save this. I will walk you through this file in a bit, right? So to run this, we're going to say Streamlit run and then app.py. Okay. Now this is going to be a very simple app, but when you run the code, you will see this local URL. You can copy this, and if we go here, so here is our basic app running. So it has a sidebar, and that sidebar has some information. And this is going to be the main place where we'll be creating our app, right? Now here, basically what you do is within the sidebar, we define a title. Let me actually do it this way. Okay, I hope it's going to be more clear now. So title, that's the title that we give it to the app, right? And then you have a markdown, like normal markdown. Within the markdown, we define the about, so that's the subtitle, and then Streamlit with the corresponding URL, right? So these are actually active links. If you click on it, it will take you to the Streamlit website, right? Similarly for Langchain and OpenAl, and then an emoji here. Now, the great thing about Streamlit is you can simply make changes here in your Python code, and you can see them right away, like what's going on, right? So for that, we will just need to rerun. I'll show you in a bit, right? So first we will use this as a starting point for our file, and I'm going to define a main function here, right? So whenever we run this file, it will be going to this main function. Now, if you want to write some text here, so the simplest way is to say st.write. It's very similar to what you will do it in a print command. So let's say hello, right? And then you save your PDF file, the Python file. And here you can just click on rerun. And now we see that we have our text shown up here. Okay, so that's how Streamlit works. But what I'm going to do is I'm going to go ahead and add a header here, right? So header is header of the page, like it's going to be shown in here. So if I save this, rerun it, now we have a header. Okay, so that's going to be the header of our web page or web app. Okay, I'm going to hide the rest of it, the sidebar, right? Because I think we were going to be working here. Okay, now next, just similar to this website, we want to provide the user where they can upload their PDF files. So for that, we're going to say PDF is equal to st, so that's Streamlit. And then we're going to say file uploader. And then we can show the user a message. So let's say upload your PDF, right? Then what type of file it's going to be. So we'll say PDF, okay? Now this will basically, if we rerun, so we have a place where the users can now upload PDF files. And there is a limit of 200 MBs per file. Okay, so this will simply upload the PDF file. But now we actually, let me show you how the upload is going to actually work, right? So here I'm dragging a PDF file. That's the US Constitution, right? And it uploaded the file. Okay, so this simply uploads the PDF file, but now we need to somehow read it. So for that, we're going to be using the PDF reader from PyPDF2 package. Okay, now in order to read it, a PDF file, here is what I did. So I took the PDF object, that's the uploader object, right? Pass it to the PDF reader, and we are going to get the PDF file itself, right? So let me see whether we can look at the object itself or not. So PDF underscore reader, right? Okay, so I'm going to save this, loaded, no issues at all. And if I upload a PDF file, we see this object. Okay, so this is great. Okay, so now we only have the PDF reader object and we need to read data from it, right? So the way you want to do it, specifically for Langchain, you want to read one page at a time. Now, in order to do that, we can do it this way, right? So there are multiple ways. I have other videos which goes through it, but an easier way would be, so for page in PDF reader, right? Dot pages. Okay. So it simply will take one page at a time, right? And then we append the text of that page into this text variable or object that we just defined, right? So we're going to call the extract text, right? So it's going to read each page and append it to this text file, right? So I'm gonna just check it whether it works or not, right? So let's do this again. Okay, let's rerun, and hopefully, yeah, okay, so good. Now what it did was it read each and every page and appended it together, right? So here is all the text that is within this constitution.pdf file. If we just completed that, we are going to be using a wrapper within Langchain that wraps around the OpenAI embedding. So that is going to be OpenAI import OpenAI embeddings. Okay. Now here's how you actually use it. So if we'll create an embeddings object, right? So let's call it embeddings equal to, and then we create that object from OpenAI embeddings. Now, so this is just the embedding object. We want to compute embeddings on our documents, right? So there are a whole bunch of vector stores that Langchain supports. So Langchain I would say embedding power, let's see, vector store, right? Let's see what it comes up with. So if we look at the documentation from Langchain, then there are different numbers of vector stores. Okay, so here is the list of all the vector stores that Langchain supports. So in this case, specific case, we are going to be using the FICE vector store, but you can use anything that you want. Okay, so the way it's going to work, we have our embeddings and we need to pass on our documents along with the embeddings. So here we are calling them equal to, and we actually need to first import this, right? So let me copy this, scroll up. Okay, so we already imported FICE. Now we can come down and then say FAIS dot, so from text. Okay, and then we need to pass on our chunks along with the embeddings. Now, there is one thing you need to be very careful about, and that is the cost associated with running it multiple times. So what do I mean by that? Every time you upload a new file, so we're going to get, like you are going to run all this code at it, and it will compute the embeddings again, right? So that will incur charges because we're going to be calling the OpenAI's API. And so with each run, that will add up to your cost. So you don't want to do that, right? So what we're going to do is we want to figure out a way that we only compute the embeddings or vector store once and just keep it on the disk for each file that we're putting it in. Now, in order to do that, let's come up with a method. So first of all, let me comment this section, right? And let me rerun this. Okay. So next, what I'm going to do is I will take this PDF object, right? And it has a field called name, right? So let's see st dot right. Okay. So PDF dot name. Okay. Let me run this, rerun this. Okay. So you see the file that we uploaded, and it is constitution.pdf, right? And then we have we are simply printing that. So what I want to do is for each file that we upload, I want to take the part of the name before the file extension, right? Compute these vector store embeddings and store those, right? So next time when I upload a new file, I will just check whether these vector store embeddings exist on disk with this file, with this name or not, right? So if they already exist, we don't need to run this part at all, right? So this will save us a lot of money. Okay, so here's what we can do. So I'm going to say with open, right? And let's give it a file name. So the way I'm going to define the file name is, let's do it this way. All right, okay, we'll just do this. So what I did was I took the file name and dropped the last 4 letters that are corresponding to .pdf, right? And then we can pass this on, store underscore name. Okay, next we are going to write it to a pickle file. I actually need, okay, so .pickle, and then we want to write this file, right? So we'll say this f, okay, and actually let me first import .pickle. So let's say import, okay, pickle. Okay, so pickle is basically for writing files to storage, right? So I'm going to say pickle.dump, okay, and then we can use the vector store because we want to write this vector store into the disk, right? Okay, so let me show you something. Now, if you see, initially we only have 2 files here, .py, the app.py and requirements.txt. And actually, we need to also store the OpenAI API key, because without that, this is going to give us an error. But let me run this and you will see what I mean, and then we can fix this. Okay, so let's do this. Then let's rerun. right? And you see validation error for OpenAI embedding, right? So it's not able to get the OpenAI API key. So we need to first provide that. So I'm gonna just actually, okay, let's do that first. Okay, so I'm gonna create a .env file here, right? And within this file, we'll type OpenAI underscore API underscore key. Okay, is equal to then the key that we're going to be using. Now it has to be exactly like this, right? Then you need to go to your OpenAI account. So let's say that's going to be platform.openai, right? In this case, I have a whole bunch of keys, but you can create a new one, give it a name, and then simply copy that and paste it here. Okay, so I pasted my OpenAI key. Here's how it's going to look like. I will delete this right after creating this video. Okay, so now we need to actually load that API key. So for that, we are going to be using from .env import load environment variables, right? So there's a function called load .env, right? So that will load environment variables. Now we can do it two ways. We just need to call this function. So you can do it here, for example, just outside of the main function, because it's sequential execution, so it will execute that code. Or you can define, or you can call that function. Let's just actually do it here. Okay, so just make sure it works. Okay, as you see, there are just 3 files. So the environment, app.py, and requirements. But if we run this now, so it's supposed to write our vector store into the disk, right? So let me save this. Let's rerun it. So hopefully we are not going to see. So I'm having this error because the file name that I give it is wrong. So env, okay? So hopefully now this will run. Let's actually save this. Save this, okay? Rerun. And okay. All right, so loading files and then successfully loaded files with this, right? Okay, perfect. Okay. Now, if you look at it, so there is a new file called constitution.pickle. Okay. Now, so we are writing it to the disk, but even if we run this again, so it will recompute the embeddings and write again to the disk, right? So first we need to check whether this file name exists or not. If it exists, so we don't write it to the disk anymore. Okay, so in order to do that, let's put a condition here. So I'm going to say if os.path.exists, right? So first check whether a certain path exists or not. So we can just copy this, put it there, right? So first we are checking that if this path exists, then we simply need to read it. So with open, that's going to be, I guess, the same thing, right? So we simply read that file since we want to read it. So that's going to be RB, right, as F, okay? And then we will read the file and store it in this vector store variable, right? So in order to read the file, since it's pickle, so we're going to say pickle.load F, okay? So basically this part reads the file from the storage, okay? Now just to make sure that's exactly what it's doing, so let's run a quick test and say embeddings loaded from the disk. Okay. Now, if it does not exist, then we want to recompute the embeddings again, right? And that's when we're going to be running this whole operation. And actually, we probably want to remove this part, right? And put it here. Okay, so let me walk you through the logic here, right? Do we have, oh, we don't have OS. I'm going to say import OS. That will import the operating system packages. Okay, So we calculated the chunks, right? Then we see that with this given file name, do we have any embeddings that exist on the disk? If they exist, we simply read that from the disk, right? If the embeddings do not exist, then we create an embedding objects using the OpenAl embeddings. Then create a vector store using files, right? And here we're using the chunks as well as the embeddings that we just loaded, and then simply write that to the disk as well. So this process will definitely help us in saving some money. Now let's test this, because we want to make sure that it actually is reading from the disk. Okay, so if I run this and it's reading from the disk, so we will be seeing this message actually. Let me add another message here. So we'll say embeddings, simply say embedding computation completed, right? So if it's a new file, then we should see this message. Otherwise, we should see that message. Okay, let's rerun, right? And it says embeddings loaded from the disk. That means it was simply reading this. Okay, awesome. Okay, so I'm going to comment this section out as well as this, because these are just for logging purposes. All right, let me just save this, rerun. Okay, awesome. Now, next we need to be able to accept an input or query from the user, right? So if you go here, right, let me just drag the file again. Okay, so now it gives us this box where we can actually ask questions, right? So we want to do something similar. All right, so in order to do that, so I'm going to say accept user question / query, right? Now, so a simple way of doing this is to use the text input, right? So I'm going to say query equal to st, that's the Streamlit, and text underscore input. Okay, and then we can simply put a message here. So we'll say ask questions about your document or your PDF file. Okay, and that's it, right? So let's run this again, and here we have an input box, right? So we can say what is the capital, sorry, USA, right? I don't know if that information is in the constitution or not, but right now, like, nothing is happening, right? But actually what we can do is we can do something like this, st.write and then query. Okay, so basically we want to make sure that whatever the input is, we are able to capture that and write it back. Okay, so now you can see the input was what is the capital, and it simply repeat that, right? Because we're just writing. If we change this to how many states are in the USA, right? So it should give me more documents, right? So in this case, there are actually 4 different documents, not 3. Okay, I think you can pass this parameter called k, which defines the number of documents that you want to return, like the top 3, 4, 5, right? And this is going to be important when we are dealing with the large language models. This is where the concept of the context window comes in, because what's going to end up happening is this step simply returns us the most relevant documents, right? Then you take these most relevant documents and feed those through the large language model. So that becomes the context for the large language model. And along with the query and this context, the large language model tries to generate a response, right? So if you pass like 4 or 5 documents, it might be exceeding the context window that the LLM has, and it's going to start throwing errors, right? So in this case, we'll just stick to 3, and I hope this is going to work. Let me run this again. And yeah, so now we are just seeing 3 documents, 001 change. It needs an LLM. In our case, we're going to be using OpenAI, and then the type of chain. Okay, so let's set it up. Okay, so first we need to load the wrapper for the OpenAI large language model. So I'm going to say from Langchain dot, this is going to be using LLMs, and then import, and then OpenAI, right? So that's the OpenAI LLM. We can actually define the type of LLM that you want to use. So for example, by default, it's going to be using the DaVinci model, but you can change it to other models such as the ChatGPT, like the Turbo GPT 3.5 Turbo, right? So I'll show you how you can do that as well. So first, let's say LLM is equal to OpenAI, right? And I'm going to use the default settings. So the default settings, the temperature is 0. I think we can set it to 0, right? You can define the model name as well, right? But let's first do experiment without that. So using the default one, and then we'll change it. And there is a reason why I'm using the default one. I'll show you in a little bit, right? And next, we also want to load our question answering chain, right? So in order to do that, we can just say from Langchain dot chains dot question answering, okay, and import. So that's going to be load QA chain, okay. So now there are two versions for this. There is this load QA with sources, I think, as well, that you can use that as well. But right now, I just want to get answers. We already looked at how to get the relevant documents, so I don't think we need that for this specific example. Okay, so we define our LLM, then we're going to say chain is equal to load the question answer chain. We pass our LLM, which is OpenAI LLM in this case. Then we need to define the type of chain. So chain type is equal to stuff. There are, I think, 4 different types that you can define. If there is interest, I can actually create more videos on it and see, explain what goes on there. So here's what we did. We got the response from the chain, right? And then we're just writing that response. So for example, here is what was how many states are in the US. So the response is 50 states. This is pretty neat, right? So that's how you can actually design a question answer system for your PDF files. Now, I just want to show you one more thing that I saw somewhere, where if you want to look at the cost associated with each and every query, right? So we can actually do that directly here, and I'll also show you how much it's going to cost you if you're doing this within the OpenAI's platform. All right. So first, we need to create a callback. So I'm gonna say from Langchain, right? Again, it's a wrapper around OpenAI, so it's going to be have callbacks, right? Then there is import get API callback. Okay. Now this will help us in figuring out how much each query actually costs us, right? So the way you do this specific part is you wrap around it with wrap around the code that you want to run. So in this case, we're getting response. So I'll say with get OpenAI callback, right? So that's as CB, okay. And then we get the response, but I will also let's say print the callback, okay. So whatever results we get from OpenAI, and we'll print that, but it doesn't really have any impact on what else we are doing here. So let's just remove this one, okay. Let's store this. Let's run it again, right? Okay, now if so there is absolutely nothing going on at the moment, but if I say how many states are in the US, right, and click enter, right, so we get a response of 50. And here, if you see at the bottom, it says tokens used 587, right? The completion tokens was 1, right? So and then the total cost associated with it is 0.0 1714. Now, in order to change the OpenAI model, I'm going to say name underscore model, or actually this was model underscore name. Okay. And then we can provide GPT 3.5 Turbo. Okay. Now, here is the difference that you will see in the response as well. Right? So let me save this, run this again. Okay. Let's ask it the same question. Okay. And run it. Right. Wait, there is an error. Oh, okay. Now it's actually saying that it's a warning. The way we're doing the model. Okay, so we directly want to use Chat OpenAI. Okay. Anyways, now if you look at the cost is much lower. That's 0.0015, right? However, if you look at the response, it says, as of now, there are 50 states in the US. However, the provided context doesn't explicitly state this information. So it seems like it couldn't find it in the documents or the chunks that the vector embeddings retrieved. But since it's a ChatGPT model, so it has information related to like the rest of the data it was trained on, right? So it's not specifically just looking at the PDF file, but it's using other information as well. Now, there are ways around it where you can restrict it. And it's, I think, way similar to what they are using. So, for example, if I ask exactly the same question here, right? So we will see a very similar response. It says, I'm sorry, but the information you are looking for is not included in the pages of the PDF provided. However, as of 2021, there are 50 states in the US. Now, this was a very long video, but I hope you learned something new. At the back end, most of the chat app applications that are out there, which says like chat with you on documents, is using exactly the same technology. If you're still here, you probably want to check out our Discord server. So we have a new Discord server over there. We talk about generative AI stuff, and I think it would be a good learning place. So I would hope to see you there. If you can and would like to support the work I'm doing, so check out my Patreon as well. You can support me there. If you have any questions, put them in the comments below, and I'll try my best to answer them. If you haven't subscribed, consider